concept under geometric progression is to find the sum of n terms of a geometric progression. Okay, so this is the sum of n terms of GP. So let us say we have the geometric progression and I want to take the sum of n terms as, say, first term is a, second term is ar, third term is ar square, and so on. If L is the last term, the last but two terms should be L by R square plus L by R plus the last term is L. Okay, now let's call this as 1. This is the sum which I want to take now. Okay, I want to find a form. But anyway, I don't have any simpler way to do this. So what I do, I multiply this equation by R, right? So that means R into this Sn has to be, this is AR plus AR square plus AR cube plus, so I have L by R plus L plus LR, equation number 2. Multiply throughout by the common ratio R. Okay, now, right, I try to perform equation number 1 minus equation number 2. So equation 1 minus equation 2 means the Sn minus R into Sn. That's on the left hand side. This is equal to, I am trying to, I can see that when I subtract second one from the first one, this cancels with this. This cancels with this. The next terms will also cancel. So I am cancelling all the terms like, okay, this will also get cancelled with the next term. This is going to cancel. This and this will cancel. L and LR will cancel whenever I do so, right? So what is left out? It is A minus LR, correct? So I am only going to retain those terms after I subtract. Okay, so this is equal to, A remains, and since second equation is being subtracted, sign becomes negative, A minus LR. So I'll try to take the Sn outside. Sn into 1 minus R is equal to A minus LR. Right. Now, this actually can be written as Sn, nth term sum, is equal to A minus LR divided by 1 minus R. Right? This is the answer. Right? Actually, this can be slightly varied now. A minus LR, whenever this R is less than 1, but I can actually modify this into LR minus A divided by R minus 1 if R is greater than 1. So we use, right, the same equation in two formats depending upon our requirement. Okay, these are the equations to calculate the sum of n terms of a GP. Moving ahead, we know that what is the value of L, but what is L? L is equal to A into R to the n minus 1. Right. So when I try to substitute this value, right, L as that, now you see the Sn changes. Therefore, Sn is equal to A minus L is equal to A into R to the n minus 1 into R whole divided by 1 minus R. So this R and this minus 1 cancels. So I have A minus AR to the n by 1 minus R. So I can take A common, A into 1 minus R to the n divided by 1 minus R. This is the equation for R less than 1. This also implies Sn is equal to A into R to the n minus 1. Only the equations pattern will change, that's all, by R minus 1. for r greater than 1. So we can use these equations as well to find the sum. All right, and the next concept here is not to find the sum of n terms, but sum of infinite terms. All right, so this next concept is the sum of infinite terms of GP. So let us first write the equation Sn itself. Sn is equal to a into 1 minus r to the n divided by 1 minus r. Okay, so I can rewrite this as a minus a into r to the n divided by 1 minus r. So can be further divided as a by 1 minus r minus a into r to the n divided by 1 minus r. Okay, now let us say I want to calculate infinite terms, right? So as n tends to infinity, that means I'm calculating infinite terms. What happens to r? R to the n becomes 0, right? Because r, right, this is for r less than 1, right? Say 0.5, 0.5 into 0.5 into 0.5, like very large number of times, because n is infinity, right? Ideally we are speaking 0.5 raised to the power infinity. That is actually close to 0. So that's why r to the n becomes equal to 0. When this is 0, this whole term becomes equal to 0, right? 0 into a minus a by 1 minus r is 0. So because of that reason, this term will not come into picture, only this remains. So, right? So this implies S infinity, sum of infinite term, is simply a divided by 1 minus r. So we need this in order to calculate the required answer, either n terms or infinite terms. All right, then let us go to an application first. So this application is the fractional representation of recurring decimal, right? So this is called as recurring decimal. So this is one application of geometric progression, right? So for example, I have the term like 0.327, and let's assume that it is denoted as 2 dots, which means 0.327272727 dot dot dot. It goes, right, infinite times, right? That is my number. But how to represent this number, right? This number, there is no representation because this takes infinite space whenever we try to save it, right? So many digits are there, so it is very difficult to save this number. So if you want to convert this into fraction, right, what is the representation? To find that, we use one of the application of GP is that we can try to convert this into the fractional format. We'll see now. So what we do now, so this can be written as, let's try to write this. This is 0.3 plus 0.027 plus 0.00027 plus 0.000027 and so on, right, up to infinite terms. So I can try to write this as, let's try to write it in this way. So this first term is 3 by 10, straightforward. The second term onwards, I have to write this, I have to convert this into a GP, right? So how to convert that? Let me try to write this as, let me take the first number out. First number is nothing but 27 divided by 1000. Okay, this is my first term. And then I'll try to write the remaining term as this is 1 plus the second term, the ratio between the second term, the third and the second term is that it's 100 times more, right? This number is 100 times bigger than the next number. So I have to divide by 100 to get this. So this is 1 plus this is 1 by 100 plus this is 1 divided by 100 is 10 square. So you can write 10,000 and so on up to infinity, right? It goes till infinity. Now, so this is equal to, let's write this 3 by 10 as it is, 27 by 1000 as it is, plus, now you see this is the sum up to infinite terms, and what is the common ratio? Common ratio is less than 1 because it's 1 by 100, right? Less than, it's a GP, right? So this is actually a GP with A equal to 1, R equal to 1 by 100 or 10 to the power minus 2. You can use anything, right? So when that is the case, I can try to write this using my equation, which uses sum of infinite terms. So that is, just see, okay, not plus, there is no plus here, it's a multiply. Okay, this, let me erase. Okay. Into, so I need to write the sum of infinite terms with this condition, a by 1 minus r. Okay, so let's do that. So this is a by 1 minus r means a is equal to 1 divided by 1 minus r is how much? 1 by 100. Okay, so this is equal to 3 by 10 plus this is 27 by 1000 into, so you see here this is 100 into 1, 100 into 1 is 100 minus 100 minus 1, so 99. Okay, let me write, this is 1 divided by 99 divided by 100. So out of which this and this two zeros will cancel, right? So my term is 3 by 10 plus 27 divided by 99 into 10, that is 990. Okay, so let's try to take a common denominator in here. So this is 990 over, so this is 990. When I take the 990 as a common, so 10 into 99 times, so 99 into 3 is 297 plus 27. So this is 324 divided by 990. So this is the fractional form of this number. So instead of saving this number, right, we can easily represent the same number which actually goes till infinity, right? So many terms, so many digits are there, infinite digits are there. You can save it using finite numbers like this. So just you can verify, enter this in calculator and check what you get, right? You will get 0.3272727, etc. Right? So as far as how many digits are supported in calculator, so many numbers, right, are actually supported over here. Okay, so that's this particular case. Okay, one problem to solve using this technique. Say I want to represent the number r is equal to 0.3258, out of which 58 is repeating. Okay, so this is 0.32585858. dot infinite times. So this is the number. Convert this into fraction. This answer r is equal to divided by 990, or I think this should be 9900. Please verify. Correct, huh? Yes. So this is the right answer. Right. That's right. So now we'll go for a shortcut to do this. So we can use the GP to go do this calculation, but there is another shortcut, easier method. Right. So any recurring what you call function, right? Any recurring number decimal is given. I will do the calculation in simple two steps. The step number one is to obtain the numerator, right? So that is the numerator is, you can simply obtain by subtract the non recurring figure by subtracting the non-recurring figure, right, from the given figure. This is the numerator, and the denominator consists as many nines as the recurring figures and as many zeros as the non-recurring figure. Okay, so number of nines in the denominator equal to the recurring figure, and the number of zeros equal to the non-recurring figure. So let's try to apply this quickly for the above problem, right? So R given here is 0.3258. Okay, so in this case, the given figure is 3258, non-recurring is 32, and recurring is 58. Okay, we have to apply that. So let's try to obtain the numerator directly. So numerator can be obtained by subtracting the non-recurring figure from the recurring figure. So what is a non-recurring figure? Non-recurring from the given figure. So given figure is 3258 minus the non-recurring figure. Non-recurring is 32, right? Remove the decimal. Don't worry about the decimal. Divide by, in the denominator, first you write number of nines equal to the recurring figure. What is the recurring figure? 58. So 58 has 2 digits. So number of nines equal to 2. So this is 99. And number of zeros should be equal to non-recurring. Non-recurring is 32, 32. Again, that has 2. So 2 zeros. You simplify this. So this comes to be 3226 divided by 9900. Right, you can verify, right? The same thing you got it. Okay, easiest way to do this. Let's solve using the shortcut now, right? So second problem using the shortcut I want you to solve. This is 1.3 okay, 1.327, right? So 1 you keep as it is, 1 plus, because whole numbers are not considered. I am trying to write this as 0.327, out of which 27 is this. So this is nothing but 1 plus, right? Subtract the non-recurring figure from the whole number, that is 327 minus recurring is non-recurring is 3, divided by, when I try to write the denominator, right, there will be number of nines equal to recurring, so that is two nines, two digits are recurring, 272727, and one digit is non-recurring, so this is 990. Okay, so simplify this, 990 plus 327 minus 3 whole divided by 990, that is 1314 divided by 990. Okay, right. Let's check the simplest one. We know the answer for this. If I give, say, r is equal to 0.3, on which I have a dot. So it means 0.33333. Right. What do? Right. From the given figure, subtract the non-recurring. There is no non-recurring. So, right, everything you have, that's only one digit you have 3, it is recurring. So this is 3 minus 0 divided by, first you write the number of nines equal to number of recurring. So there is one digit which is recurring, that is 9. And there is no 0 coming into picture. That is just because you don't have any of the non-recurring digits. So this is actually 3 by 9, that is 1 by 3, right? So we know that. So that's how you try to write in this way. Okay, easiest way. So most of the time we get one question based on this in the exam. All right. The next, let's go for note, where we try to write some shortcut formula. Okay. Right. So the first one we should remember is this. If you have something like A plus AA plus AAA plus dot dot dot, right? If this is given for all the A belonging to the natural numbers, and right, the A is between 1 and 9, equal, including both, right? It could be something like, let's say I'm trying to write an example, but before that let me give the answer. This can be directly replaced by, this is equal to A by 9 times 10 by 9 into 10 to the n minus 1 minus n, right? So A plus AA plus A up to n terms, right? So, right, whenever I say find the sum up to, say, 6 terms, right? So that is A, like that, 6 terms. Okay. So now, for example, let's try to write. If at all the given number is something like, say, 4 plus 44 plus 444 and so on up to n terms. If this is asked in the question, directly you can write that is equal to, replace A by 4. This is 4 by 9 into, this is 10 by 9 into 10 to the n minus 1 minus n. Now if n is equal to, say, 6 terms, right? Simply put n equal to 6. You will get the answer up to 6 terms. Okay, so that's a note number 1. Right. We have another shortcut formula to remember. So this is like, say, 0 point B plus 0 point BB, 0 point BBB plus dot 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 up to n terms, right? For all the B's belonging to natural number and 1 less than or equal to b less than or equal to 9. If this is the case, then the shortcut answer, direct answer can be written like this is b divided by 9 into this is n minus 1 by 9 times 1 minus 1 by 10 to the power n. Let me check. B by 9 into n minus 1 by 9 times 1 minus 1 by 10 whole raised to the power n. Yes. Okay, this is the shortcut answer we can directly write. For example, let's say we want to calculate say 0.5 plus 0.55, 0.555 dot up to n terms. All right, if you want to calculate the n terms, then this can be written as equal to 5 divided by 9 into this is n minus 1 by 9, 1 minus 1 by 10 to the n, right? Simply substitute the n value like, right, I want 10 terms, put 10 over there, and you will get the answer straightforward. All right, let's solve few more problems. If the Sn is equal to 1 plus 1 by 2 plus 1 by 2 square, 1 divided by 2 to the n minus 1, find the least value of n such that 2 minus Sn is less than 1 by 100. Okay, so this is a given question. I have to satisfy this condition and find the least value, okay, of n. All right, what is the minimum value which satisfies that given condition is the question. All right, so let's try to solve this. Let me write the Sn. Sn is equal to, I can see that this is sum up to n terms. As I know, it is a, Sn is equal to a into 1 minus r to the n divided by 1 minus r, provided this r is less than 1. So I can see that this is satisfying for the given problem. I can directly write Sn is equal to a is 1, first term, 1 minus r is equal to half. So half to the n divided by 1 minus half. Okay, now let's try to simplify this. So left hand side I still have Sn, and let me try to simplify this. So this is 1 minus 1 by 2 is 1 by 2 in the denominator, which is 2 in the numerator. So 2 into 1 minus 1 by 2 to the n, right? So this is equal to 2 into 1 is 2 minus 2 times 1 by 2 to the n. Okay, so this can be written as 2 minus there is a 2 in the numerator and 2 to the n in the denominator. So Sn is equal to 2 minus Okay, the 2 in the numerator, I'll try to take it to the denominator. So this is 1 divided by 2 to the n minus 1. Okay, now let me try to move the Sn to this side and 2 to the n minus 1 to the other side. This implies 2 minus Sn is equal to 1 divided by 2 to the n minus 1. And it is given that this should be less than 1 by 100. Right? When I bring this to the numerator, right, I have to bring the 2 to the n minus 1 to the numerator to satisfy this condition. So that means 2 to the n minus 1, according to the rule of inequality, when the denominator goes to the numerator on the unequal sides, so you have to change the unequal sign. If it is lesser, you have to make it greater. If it is greater, you have to make it a lesser. Now you can see here, this was a lesser sign. It changes to the greater sign when the numerator and denominators gets exchanged. So denominator has 100 and it comes to the numerator like 100. So which is the value of n, right, that exceeds this condition, right? 100 is actually, I can write greater than 2 to the 6, right? So I can say that 2 to the n minus 1 is greater than 2 to the 6. That implies n minus 1 should be greater than 6. So as n should be greater than 6 minus 1, so sorry, 6 plus 1, right? So that is equal to 7. So n should be greater than 7. So at least n should be greater than 7. So what is the minimum value satisfying this condition? That is, minimum value is 8. That is the required answer. All right. Okay, let's look at some more points to remember related to GP. Right. So if, let's say, we have three terms, A1, A2, comma A3 are in GP, this implies, right, say k times A1, comma uh, k times A2, comma k times A3, right, also in GP. Okay, this also implies A1 by k, comma A2 by k, comma A3 by k, also in GP. So dividing by the constants will not change their progression. Okay, you multiply, you divide, still remains same. Okay, this also implies 1 by A1, comma 1 by A2, comma 1 by A3, also in GP. The ratio will change, common ratio will definitely change, but you see that is also going to be in the GP. And this also implies A to the n, A1 to the n, A2 to the n, comma A3 to the n is also in GP. Again, in this case, the R will change. Common ratio is going to change, but definitely GP will be there. Okay, then make a note. If this is the case, if I take the log term, right, log A1, comma log A2, comma log A3, right, is in not GP, it is in AP. So A1, A2, A3 are in GP means log A1, log A2, log A3 will be an arithmetic progression, right? Very important. Okay, then let's move to the next point related to the GPs. So here, uh, let's say if A1, comma A2, comma A3 in GP and B1, B2, B3 in another GP. They are completely different GPs. Okay. Say if at all we have two different GPs with the terms like A1, A2, A3 in the first one, B1, B2, B3 in the second one. So let us try to have different common ratios here, right? So A1, A2, A3 will have the common ratio as say R1, and B1, B2, B3, etc. will have the common ratio as R2. Okay, then this implies A1, B1, comma A2, B2, comma A3, B3, right, is in GP, right? So here the R becomes R1, R2. At the same time, A1 by B1, A2 by B2, A3 by B3 is also in GP, such that R becomes equal to R1 divided by R2. That will be the new one. But if you add or subtract, like A1 plus B1, A2 plus B2, A3 plus B3, or A1 minus B1, A2 minus B2, A3 minus B3, that will not be in any progression. Okay, so kindly note that. Okay, that's not a point I'm going to write here because that's obvious. Only multiplication and division will work in the geometric progression. Okay, let me write the next point. A1, A2, A3, dot dot dot. Let me write some of the last terms as well. That is an minus 2, an minus 1, and an. They are assumed to be in GP. This implies we had a similar property in AP, right, which was to take the sum of the first and the last term, sum of the second and the second last term, etc. But now it's not about a sum, it's about a product. So that is A1 into AN is equal to, right, this is A2 into AN minus 1, right, which is also equal to A3 into AN minus 2, and so on, right? Also, you can write any term AR is equal to root of, AR is equal to root of A R minus K into A R plus K. Okay, so for all the K between 0 to N minus R, this is going to work, right? For all, let me write like this. So 0 less than or equal to K less than or equal to N minus R, this is going to work. Okay. Then we have the ratio like A2 by A1 is equal to A3 by A2, that is also equal to all the terms up to AN over AN minus 1, right? So I already know that. I can try to write this actually implies I can derive something else, that is A2 square. A2 square is equal to A1 A3. Or I can also write, maybe the next ratio would be, this is A4 by A3. So if I try out, I can also write A3 square, that is A3 square is equal to A4 A2, and so on. I can do this. Okay. So this is actually going to work for any function, any term we want to. Okay, now all right, let's move further. Let's try to solve some problem. This is a question. If the continued product of three numbers in GP is 206, and the sum of their products in pair is 156, right? Find the numbers. Right. See, whenever three numbers are given, I can assume it as AR into AR square, right? That will work. It's going to, we will be able to solve the problem for sure. But that's going to take a longer, that's going to take more steps, more time. So the suggested technique is this. Whenever three numbers are given, it is expected that you will consider the three numbers. So let the numbers be, so you take like this is A by R comma A and AR, so that when you take the product, the R cancels, right? If you take AR square, there are two unknowns in that equation, that is A and R. But if you take like this, then you apply this. So this implies the product A by R into A into AR is given as 216. So AR and R cancel. So the initial number A cube is equal to 216. Okay. When A cube is 216, you can say that A is equal to 6. Yes, I got the first term. And the next part is that if you take the sum of their products in pairs, then that becomes equal to 156. So that's going to give you the value of R easily. So that means The first term is a by r into a. I have to take the sum, but it's a product, right? First should be taken first. Second term, right? It's a into ar. That's the second product. And the third product is ar into a by r. This is given as 156. All right. So let us try to simplify this here. If I take, I think a square is common in every term. So a square is taken out. Here r cancels. So I have 1 by r. In the second term, I have r. And the last term is just 1. So this is equal to 156. So a can be substituted as 6. So 6 square, 36. So I take the common denominator here. So r divided by, this is 1 plus r square plus r is equal to 156 divided by 36. Okay, so 3 and 30. So let's cross multiply. 3 plus 3r square plus 3r is equal to 13r. 3r square minus 10r plus 3 is equal to 0. So solve for r. R is equal to 3, or I think 1 by 3. So let's check that. If I should be able to take the product, it should be, so let's try to find the numbers now. One is a, so a is equal to, we obtained a as 6, and r is equal to, right, I can even take 3 or 1 by 3. So if you take 3, so a by r is 2, 6 and 18, right? 18 plus 2, 20 plus 6, 26. So 2 into 6, 12 into 18 gives a 216. Yes, this is the answer. So these are the numbers to satisfy the given question.